class. So I'm just going to quickly try to go over each one of these, which means it's not going to be super quick, but so for the x component of the force of gravity on a hill, right, you just have a hill, your force of gravity is down, whatever angle here ends up being your angle up here. And so we have our y and our x. Your x is going to be your sine, so it's going to be mg sine theta. The equation for voltage divider. So this applies in series. Basically, whatever the resistance of your thing is over your total resistance of both of them times your total voltage will get you the voltage for that particular thing. Second kinematics equation is your final velocity is equal to your initial velocity squared times or plus 2a delta x. What's the equation for average velocity? This is delta x over t. This is always true. Well, you can always get an average. The meaning of a force position graph, the area specifically is your work, because that's going to be force times distance, aka the work. What is the equation for momentum? Hopefully you know momentum is mass and velocity. Kirchhoff's junction rule is that all of the current into a junction must be equal to all of the current out of a junction. And this is conservation of charge. So basically, just like we don't lose energy, we don't lose mass, we don't randomly lose an electron on its path. It started somewhere, it's going to end somewhere. All right, how do you calculate power in an electrical circuit? That's P equals IV is your standard one. There's a lot of different ways you can do this because remember, V equals IR. So you can often substitute in different things for this. All right, and then what's the meaning of the area of an IV graph? So if you have a voltage and a current graph, and you have some area, and that's power, right? Because if you multiply them together, you're going to get power. Next page. All right, so what's Ohm's law? Ohm's law is that V equals IR. So what does it mean for a resistor to be ohmic or non-ohmic? Basically, that means if we plotted the voltage and the current, the resistance should be constant. It should be a straight line. So basically, your VI graph should be a straight line. If your VI graph is not a straight line, that means as your current increases, your resistance changes. And that is what it means to be non-ohmic. So our resistor is ohmic if it follows V equals IR. Our resistor is non-ohmic if it does not necessarily follow this, and normally that's because the resistance itself changes. All right, spring potential energy is going to be that 1/2 k delta x squared. Don't forget the square, it's common. Average acceleration is just the change in velocity over the change in time. This is always valid. Okay, you can always find the average. The moment of inertia is for some point mass. So this is basically the rotational inertia, the basic equation, which is mr squared. What is heat? What types of forces cause heat? Heat is just another name for negative work. So what forces often cause negative work? Friction, specifically kinetic friction. Alright, what's the meaning of a slope of a VI graph? So whenever you're trying to figure out what is the purpose, equations are really useful, and that's going to be your resistance. Because if I divide V divided by I, I'm going to get the resistance. Alright, if things are in parallel, REQ is going to be taken as a fraction. And that just means, and you keep doing that for as many resistors that you have in parallel. Equation for work is just force times the distance. Remember though, work is also known as just any change in energy. That's because of an outside force. But you can also often find work without this equation. You're just looking for a change in energy. But that's the official equation. All right, remember elastic and inelastic? Elastic means both, I think my screen is a little broken in this area, both momentum and kinetic energy are conserved. Inelastic, only momentum is conserved. Next page. Alright, so acceleration from velocity, I should have said velocity time graph, so your acceleration is going to be your slope. Change in energy equation, so you could say your change in the net energy is because of either whatever work or is because of whatever your energy final minus your energy initial. Equation for heat, this is just a negative work equation. Kirchhoff's loop rule, so this is the voltage rule. It's the idea that for so the voltage of one whole loop minus the voltage from each resistor will always equal 0. And so this is conservation of energy. So the idea that your electron is not going to go home until it's used all of its energy. Therefore, for it to use all of its energy, for every loop, all of the voltage or all of the energy must add up to 0. So whatever energy you start with, it gets lost at each resistor, ultimately summing to 0. An ammeter measures the amps, i.e. the current, and this should always be hooked up in series. Because remember, things in series have the same current, so if you want to measure the current, you hook it up in series. Tangential velocity is going to be ET over 2 pi r, so the distance over the time it takes, or the period, the time it takes for one full rotation. So basically the circumference over the time. Equivalent resistance for series, this is nice and easy because it's literally, you just add them for as many as you have. A voltmeter measures, you might have guessed it, the voltage, and it should be hooked up in parallel. Because remember, things in parallel have the same voltage. Equation for period of a pendulum. So remember that 2 pi is going to hang out there on the outside, and if gravity is increased, this is how I remember, if gravity is increased, your period, it's going to get large, dang it. No, it's going to get smaller, right? The more gravity is, the less time it takes, but the longer it is, the more time it will take. Alright, next page. Alright, so how do you find displacement from a position graph? You read the graph, right? It's there. Alright, if we were to draw a diagram of a harmonic of an open-open, this is the first harmonic. An open-open system, remember both sides are going to be open. This is going to be right here. This is only half a wavelength. A restoring force is a force that goes back to equilibrium. So it's a force that is trying to go to equilibrium. So like if you pull your spring out of the way, it's going to have a restoring force trying to get back to equilibrium. All right, period of a spring. So again, we have that 2 pi hanging out. And then we're going to know that if I have a heavier mass, it's going to take longer, and if I have a higher spring constant, it's going to take less time. Impulse is the change in momentum. All right, define amplitude of a pendulum. Amplitude for a pendulum is the amount of degrees from the center. It's normally how you define it, or the distance if we're abbreviating. How do you find the impulse from an FT graph? So if you have force and time, impulse is force times time, so we are looking at the area. What does oscillation mean? It means back and forth. Two examples are a pendulum and a spring. But that's pretty much what it means, back and forth. Amplitude for a spring. It's the displacement from equilibrium. And so this is most often measured in meters or centimeters. Alright, so define power and give two basic non-electrical equations that can be used to calculate power. So our standard one for power is that power is equal to work over time. The less common one, however, is force times velocity. And that kind of seems weird, but if we think about it, work is joules over seconds, and a joule is a Newton times a meter per second. Force is a Newton, velocity is meters per second, and so you can see that we have newtons times meters per second either way. And so both of these equations work for finding power. Right, the period of an harmonic oscillator is just the time it takes, time for one cycle. All right, and the equation for frequency is 1 over the period. Velocity on a position time graph is the slope. Ohmic, again, ohmic is whether or not it follows Ohm's law, and how could you test whether a light bulb is ohmic or non-ohmic? So if it's ohmic or non-ohmic, you pretty much just need to make a graph and check, is this linear? If it's linear, it's ohmic. Non-linear, non-ohmic. Alright, angular displacement and acceleration, but we're here looking for the equation, and so that is, you could either do the idea that the displacement is equal to this times the radius. Alright, remember our original values are just these times the radius, or you could do the fraction version of these, such as theta is going to be equal to delta x divided by r. All of them work. I don't want to write all of them. Alright, equation for gravitational potential energy. So it actually depends if we're talking about big G or little g. Little g is just going to be mg h. Big G is going to be m, and just one r, no squared. Basically because the radius, remember this is just your force times your displacement, and this is also your force times your displacement, which is going to be your radius. So both of these work. This one here is obviously at the universal scale. I've only seen like 3 questions on it, but who knows? Alright, equation for kinetic energy. You guys normally have this one down, 1/2 mv squared. Wave speed, v equals lambda f. You could write this in any way, shape, or form. Next page. Alright, so a damped harmonic oscillator is just an oscillator that loses energy. So energy is not going to be conserved. And so as far as how that looks, that means that our amplitude decreases. The wavelength, although I didn't do a great job showing it, stays the same, but we do have an amplitude decrease, because remember, amplitude is the way that we show energy. All right, two equations for torque. You have either torque equals the force times the perpendicular radius, or torque is going to be equal to your rotational inertia times your rotational acceleration. So I'd same idea of F equals ma. Alright, the y component, we already talked about this, so the x is sine, the y is cosine. So for any object accelerating in a perfect circle is going to be your centripetal acceleration equation, which is AC equals v squared over r. Two equations for impulse are going to be force times time, or your mass times your change of velocity. Alright, first harmonic of a closed open system. So if it's open, it's going to be a wide end. If it's closed, it's going to be a tiny end. And that's only a quarter of a wavelength. Under what circumstances is energy dissolved? If there's no outside forces. So that means all the forces are in the system. Alright, how do you calculate the frequency when you hear 2 beats? We didn't really talk about this in class, but the short answer is it's extremely easy. It's just frequency 2 minus the frequency 1. And it's the absolute value, so it's always going to be a positive number. And so that's the frequency of a beat. Alright, Doppler effect is when you have an apparent frequency shift. So remember, the actual frequency doesn't just change, but it sounds like it does. Alright, so difference between transverse and longitudinal. So transverse waves go in the same, transverse waves perpendicular to their propagation. So transverse waves move perpendicular to the direction of the wave. Longitudinal waves move parallel to the wave. And so what I mean, right, is your transverse waves, the medium goes up and down, but your wave ultimately travels left or right. Your longitudinal waves are like your slinkies, where the medium would go back and forth, and your wave ultimately was going in the same direction as them. Alright, first kinematics equation, delta x equals v naught plus 1/2 at squared. How do you find the position from a velocity graph? Area. What factors does the speed of sound of a wave depend? This is on the medium, which, if you're talking about in air, that means the temperature. And so a lot of you guys on your wave lab, that was the main idea, is that it's burning. The whole thing is burning. Its temperature is not at STP, which means you're going to have a very different wave speed. Equation for kinetic energy. We've already done this one, but you know what? It's an oldie, it's a goodie. 1/2 mv squared. Angular momentum. So there's two. One is L equals your rotational inertia, so your mass times your rotational velocity, so mv. The other one is like many other things. If you take it and you add a radius, and look, it's angular now. Alright, so equation for the force of friction. Force of friction equals mu times Fn. Acceleration due to gravity, so that's g equals gmr squared. And what conserved means, it means saved, or initial state is the same as the first state. Or initial state is the same as later state. Next page. Alright, so under which circumstances are the first three equations I put when acceleration is constant? They must be constant. Alright, rotational kinetic energy is this. When do you want to use it and when don't you? It's pretty much when object is spinning. If it's not spinning, you can probably just use your run-of-the-mill kinetic energy equation, and I would go for that first chance. Closed harmonic, it's still going to be 1/2 a wavelength. It's just going to look a little different. Equation universal gravity, Fg equals Gmm over r squared. Coulomb's law. Oh man, was I not recording the whole time? Bother. Anyway. Hopefully it stands for itself. Anyway, resistivity, how is it related to resistance? Resistivity is the innate resistance of the material. And so this depends on its length and area, which we're probably really not going to get into this year, so don't worry too much about it. True or false, acceleration is equal, kind of, it has to be change in velocity over time. It can't just be any velocity, it has to be a change. Alright, if a ball is thrown at some angle, it really doesn't matter because at any point the acceleration is down and 10 meters per second squared. When an object of mass m, what is the x component? That's our mg sine theta. If an object in, ooh, I have so many repeats in here, I need to fix this. Cosine theta. If it's at the highest point, which direction is velocity? Horizontal. So it doesn't specify right or left, but the main thing is that at the highest point, its velocity is horizontal. Left, right, doesn't really matter. Equation of gravitational field, G equals Gm over r squared. Units for energy are joules. In experiment, some object moves, so we're doing some graph of 1 over r, while our net force is on this. So remember, that's off the equation, the force equals ma, which is our v squared over r, so that means our slope is going to be mv squared. Alright, so if we rebound, if we go down at 3 meters per second, and we rebound at 3 meters per second, our change is 6. And remember, we're looking at momentum, so it should be newtons times seconds, because there's that 1 kilogram in there. If an object is in free fall, does the gravity do positive or negative work? And so specifically it says it's rising in free fall, so it means it's moving up, but gravity is pulling it down. Therefore, it's going to do negative work because the force and the direction of the displacement are in opposite directions. Ooh, last one. Work on force displacement graph. Area. Again, I'm pretty sure this is a repeat. Is energy a scalar or vector? It's a scalar. What is mechanical energy? That's potential spring energy, potential gravitational energy, and both your kinetic energies. How is angular impulse related to angular momentum? Extremely similar. just like angular momentum is, let me erase that. Just like angular momentum is like normal momentum, angular impulse is like normal impulse, which means if you have any change in your velocity, you'll have a change in your momentum, or if there is an outside force, or in this case an outside torque, over some time. The coefficient of friction was the coefficient of friction if someone heavier lands on it. It's exactly the same. The coefficient of friction has nothing to do with anything besides your two surfaces. Alright, if we have a block has some momentum and it moves towards another block, what's the magnitude of the system later? You add them. You just add them. Or in this case, it doesn't really specify, so you either add or subtract them. But you're either going to get one of these two answers. It depends on how you imagine it. Poor wording on my part. Alright, anyway, I hope this was helpful. And, oh, and sorry, I forgot the other one. This turns into this if you just do some little bit of derivation. These are your two big ones. Alright, hopefully this was helpful, and I will talk to you guys later. Bye.